Welcome to the Smart Living Spaces vlog. I am Sharon, architectural and passive house designer. I'm also a homestay professional located here in New Zealand. It's my mission to make healthy, comfortable, energy efficient and affordable homes for everyday people. So come on a journey with me where I share my knowledge gained over the last couple of decades, because we aren't going to be building better if people don't understand and see the value in changing what we are creating. Well, welcome to 2025. Usually I write a blog every single month, but this year I'm deciding to try something a little bit different, and so I'm going to be recording my blog as a vlog. So you get me talking rather than writing. But this month in January, I'm covering in my social media posts better building solutions and focusing on building products and systems, because so often I see substitutions made by builders and clients on site that actually has a big impact on the performance of the building. And a builder might have said to a client, look, I get this product from this merchant, I get a good deal on it, why don't we substitute that for this? And they're convinced to settle for status quo, because a lot of builders do what they've always done and what they've always known. And I'm in the space of let's have innovative new building solutions, because to be honest, if the way that we have been traditionally building and designing buildings was going to allow us to build better, we would have already done so. So this is going to just highlight some of the reasons why architects and designers and people in the building better space have chosen certain materials. I am impartial, so I can recommend any building product and any building system. I'm not I'm not beholden to any partnering kind of relationships. There is a lot of confusion and curiosity about building better. So buildings are a system made up of parts, and those parts need to perform as expected, and they also affect how other parts of it operate. It's no different to a car. All the parts in a car need to form the solution so it's drivable and that it's safe, but that it can also be efficient in terms of fuel consumption, etc., etc. A house is no different. So if we view a building as a kit set of parts, let's talk about the parts that I use in combination with others for building better. All right. So first up, Formance SIPs panels. This is a great story behind SIPs panels. So behind the Formance product. After the Christchurch earthquakes, Nick Hubbard and William Hubbard Googled earthquake-prone buildings, and they discovered SIPs panels. And so they started their SIPs panels journey, and they're very new to the construction industry at that point. They have come a long way. They've learnt a lot. And sometimes we need people outside of the construction industry to step into that space to actually bring innovation to our industry, because we can get stuck in status quo and we've always done what we've always done. So therefore, why do we need to change? These panels now are made in New Zealand. So it's a New Zealand business success story. And part of sustainability for me too is supporting New Zealand businesses and New Zealand economies in our New Zealand economy. The great thing about SIPs panels is that they are offsite construction, so that they can add speed to a project, and they can make a project more affordable. Now, of course, there needs to be smart on-site management and knowledge of the builder of putting these panels together to capitalize on the smartness of the offsite construction and the capital investment. So SIPs panels work as the insulation, structural air tightness and weather tightness elements for floors, walls and roof elements. Insulation and air tightness are areas that Building Better addresses and is quite intentional about. They're areas that conventional construction kind of touch on, kind of don't consider and just assume. So the insulation values that the SIPs panels can offer us far exceed the insulation values that we can achieve with our stick frame buildings when we stuff insulation in between the voids that are left. So it is a superior product in terms of bang for buck in terms of thickness. Also, thermal bridging is a big part of thermal efficiency. Thermal bridging is the weak spots that we get in a structure. Now, conventional stick frame buildings, we assume in our generic calculations that we'll have 12% timber there. We actually end up more close to 34%. And because our insulation layer and our structure layer and our wall and roof framing are shared, the more timber you have in wall framing, the less insulation you have in that wall. The more timber you have in your roof and your truss element, the less insulation that you can have in your ceiling space. So designing out those thermal bridges is quite key, and Formance has a system that is able to do that. So as a designer, I know when I use their system, I know that I'm designing to a system that's not only designed for minimal thermal bridging, but is also going to deliver on site minimal thermal bridging. There's no guarantee of that happening when you're using conventional trusses and wall framings, because wall framers and truss framers don't actually understand building better and thermal bridging as a concept. The more timber they can shove into a frame, the more money they make. So that's one of the reasons why we end up with 34% framing on average. So we get a compromised building straight away with conventional methods. The Formance SIPs panels design manual and the design methodology, and with their programs that they run with builders. Once you've got a project up and designed and consented and ready to start on site, ensure that the design intention for better air tightness, better thermal bridging, better insulation values, and better speed of construction off site actually happens and is delivered for you as a client. So Mammoth Insulation, this is another New Zealand success story. It's a New Zealand family-owned business. Mammoth is polyester insulation. The factory has a recycling program, and it takes offcuts from site. It also takes off-site waste that is generated by the polyester during the manufacture process, and it recycles back into the insulation. So polyester is a recyclable material. There's a few other reasons why I love Mammoth. I have it in my own home, so if it's good enough for me, it's good enough for my clients. Firstly, this is the only insulation product made in New Zealand that is independently tested in situ, rather than using generic calculators for generic values. Its performance in situ in certain situations actually exceed the generic values. Now, just to highlight with our values, we talk about product R values when it comes to insulation products, an R of 2.8 or an R 3.6. But our New Zealand building code and building modelling and building methodology focuses on construction R values. So that is the actual thermal performance of the entire element together, which is why when you have more timber in a wall framing, you have reduced R value of the construction element, which is why it's not just the R value on the tin of an insulation product that determines whether you're going to get a better building or not. The second reason why I really love Mammoth Insulation is that it's friction fitted. What this means is this is because it's structurally stable, it doesn't sump, there's no air gaps around the product when you put it into framing, because air gaps around the product reduce its effectiveness, and if we have a product that sumps, we're going to create voids with no insulation and therefore really large air gaps. So also, if you squash glass fiber insulation, this is like your Bradford Golds and your pink bats. If you squash it, you actually compromise the performance of the insulation. Glass fiber insulation cannot be squashed and compressed. It has to sit there and fill its space with being fluffy. Now, Mammoth insulation comes in, it's quite solid and it's quite dense, and we know it performs at that thickness and that density. And so you can't shove it into spaces. So the installation of it is kind of a little bit foolproof. You can't just have someone roughly just smash it everywhere and naively think that we're going to get a better performing building. Mammoth is more expensive than its competitors when you compare R value to R value. But if you're not looking at the outside, the bigger picture of how that product is installed and how it's going to perform in situ, then yes, you're going to get a false economy on the fact that another product might be cheaper. But insulation is really cheap to get right at the beginning when you're installing it and you're doing a new build or you're doing a renovation project. It's incredibly expensive, particularly in your walls, to retrofit it. So don't regret the cheaper option. Invest in the right one at the beginning. Starke Joinery is another one of my favorite products. This is a New Zealand company again. It's active in the building better space. They're located in Auckland. So the Starke factory is big into lean manufacturing, and lean is a core value of offsite manufacturing. It's a smart way of making a product. And if we're going to look at affordability in buildings, we need to look at making building products smarter. So lean manufacturing is a methodology that focuses on minimizing waste within the manufacturing systems while simultaneously maximizing productivity. And I've been into the factory, I've been shown around the Starke factory and the uPVC Starke factory, and the machinery that they've used, they've imported from Europe, and it is super smart and super efficient. The other reason why I like this joinery is that uPVC's thermal performance is far superior to aluminium. Now, we've used aluminium historically and traditionally and conventionally in the New Zealand construction market for many, many decades. But I'm going to explain to you why aluminium is not a great choice of material. I'm going to tell you a little story about thermal coefficients of materials. So thermal coefficients is this big fancy scientific number that says for 1 meter thickness of this material, this is how much energy will be transferred across this 1 meter thickness of material for 1 degree Celsius of heat loss. So in other words, the higher the thermal coefficient number of a material, the more heat loss you're going to experience faster across that material. So the thermal coefficient for aluminium is 160. It is, apart from being a high embodied, carbon embodied material, it's also a really good conductor of heat, which means it's very poor performing when we're wanting to have low thermal conductivity in our materials. Now, the thermal coefficient of the fluffy stuff that we put in our walls is the generic value for this is 0.035. 0.035 compared to 160. Now, uPVC, the thermal coefficient, if you had 1 meter of uPVC and 1 meter of aluminium, would be 0.18. So that just highlights the difference in performance that we're getting, and the reason why we have to thermally break aluminium is because of that high number of 160. We have to put plastic in between the two pieces of aluminium frame in order to improve its performance. So let's not use poor performing materials. Let's use a system that uses better performing materials right from the start. Now, there is a myth that uPVC won't stand up to New Zealand's climate. We all have heard stories about the hole in the ozone and the fact that the sun here is really, really harsh. And it is harsh. Now, we all remember the plastic downpipes and that are brittle and that are broken, and the old plastic spouting that looks awful on those old houses. Marley spouting is a household name. We see it on TV in the adverts. Marley spouting is made of uPVC. It's the same material that Starke's uPVC joinery is made from. In fact, the offcuts from Starke's factory go to Marley. So they've got a good recycling agreement with Marley. And Marley spouting and downpipes are very popular today, and we don't see them breaking down, and we still see the New Zealand public embracing them and using them. So that's an excuse to say that we cannot use uPVC joinery because it won't stand up to New Zealand's climate. So uPVC is an unplasticized polyvinyl chloride. In simple terms, that means that it's PVC minus the plasticizers. And historically, those downpipes and those gutters used PVC, not uPVC. So when we skip the plasticization process, we get the uPVC, which is a rigid, robust material with many applications. And as I said, Marley use it today. And I do also want to point out that while people still might say, but I still like the durability of aluminium, the powder coating that we put onto our aluminium joinery, the one that you can choose any color that you like, that powder coating is plastic. So if we're going to have an issue with uPVC and plastic windows and doors, we've got to ask about that coating that we put on our aluminium to stop it from corroding. So let's ditch the untrue stories about uPVC and let's use it to build better. So Starke have a ambience range, which is a recessed uPVC range. When we recess our windows into our thermal envelope in our walls, and if you're recessing them into your roof element, you get better performance because hanging a unit over the outside of the cladding is where we get a really poor installation detail. It's a very common conventional installation detail. So the other thing that I love about Starke is that they have got this, what they call a code mark. It's an alternative solution. So it's not the generic conventional way that many people do it, but we can pull the window in line with the thermal envelope, which means that we get not only a better performing unit, we also get a better performing installation. So we're plugging the weak spots around the window, as well as the weak spots that the frame gives us. There are stories about uPVC being more expensive than aluminium. We did see a change in H1 in December 2023 that increased the minimum values that you need generically for the schedule method for windows. Because uPVC is better thermally performing than the aluminium, we can bring the performance level of the glass down so that we can match performance for performance, because we're not having to use a higher performance glass to compensate for a poor performance frame, as in the case of thermally broken aluminium. And so because we're now starting to see performance being equaled out, not just matching sort of like for like, not quite accurately, we're starting to see that in certain situations, uPVC is actually coming out cost equivalent, if not cheaper, than thermally broken aluminium. So, because you're not having to compensate with this really expensive glass for a port frame. And when we start to see thermal modeling become more and more prevalent in building, we're going to see that installation of that joinery unit play even more of a role in quantifying performance. Now, smart meters from Basis. This is a company I recently became aware of. It's made in Auckland. It's a New Zealand company. It's an initiative. These guys have been working on it for 4 years. Basis are smart meters, and they're a game-changing smart panel that makes old school switchboards a thing of the past. I'm just going to read a bit that I copied off their website. It's the world's first smart panel and app that provides unparalleled insight, control, and safety for your home. Instead of a mysterious box of wires on the wall, the Basis smart meter is a digitally connected device that provides real-time insight and control over energy use in your home. Unlike traditional electric panels, Basis Core sheds light on your energy use, revealing power suckers, finding savings opportunities, and supercharging your home's electrical health. It's a power revolution in your pocket. They've got a Basis Core and a Basis Future. Basis Future doesn't just save you money, it makes you money. It includes every feature from Basis Core and Basis Control, plus the ability to export power to the grid and advanced overload protection. So check these guys out. This technology is going to be a game changer for lower power bills and better building in our homes. And it has huge potential to work with energy efficient design, because if we design buildings that require less energy to run, and so therefore have a energy efficient design, and we then work out the demand that is required by that design, when we then reduce the amount of PV panels that we need to install to generate power to match that demand, and when we have smart technology that bridge the two, we really are designing smart energy efficient buildings. Steibel Eltron, this is German engineering at the best. Steibel Eltron manufactures both heat recovery ventilation units and also hot water heat pump systems. Now, when we put these two systems together and design them together, we get efficiencies in operation. Heat pump hot water cylinders are far more efficient than our conventional electric hot water cylinders that we install. And when we are looking at the unsustainable resource of gas, they're a much more environmentally friendly solution. The cost of running gas, I think, is going to get more and more expensive as we go through, and also our gas supplies are eventually going to dwindle. As we move to more homes investing in PV panels, it makes sense to use more electrical savvy appliances and maximize our investment of any PV panels that we put on our roof, or maximize the investment of buying power off the grid from our electrical supplier. The mechanical heat recovery ventilation side of things is important, because this recycles heat in the cooler days back into our internal environment, so that it reduces our heating load. That saves us power. It also brings in fresh air. Our windows only ventilate our spaces effectively roughly about 10% of the time. And so we're not actually getting fresh air to healthy standards in our conventional constructions. But because it's the minimum requirement of 10% windows per habitable floor area per room, it's a tick the box exercise, and everyone just assumes that it works. So let's not design to minimum standards in our New Zealand building code. Let's not let legal standards dictate building performance. Let's use a ventilation system to definitely bring in fresh air. It also means that internal humid air that has been saturated with water vapor from cooking and showering, and even our breath and our own activities, we breathe out 3 litres of moisture a day. It means that this unit will ensure that we remove that moisture-laden, humid, carbon dioxide-soaked air on a regular basis that's needed for our health. So humidity is a key issue when it comes to respiratory illnesses like asthma and also mold growth. So homes that children experience asthma in are damp. They're not necessarily damp, cold homes. They can be damp, warm homes too, and mold can grow in damp, warm homes too. So it's not just the old leaky villa that we need to be aware of for ventilation. In fact, it's probably more so in our newer construction because it happens to be more airtight. So the mechanical heat recovery ventilation unit helps with fresh air, ventilation, condensation control, heat recovery, And in summer, we can boost the fan. So if you do have any hot pockets or you do have rooms that have overheated in summer, you can move that air pretty quickly. Of course, we want to stop overheating other ways and smarter ways, but you do have that boost option. And if you have a party and it gets really warm inside, you can just boost it too. Thermally treated pine. These are the two brands, Lunawood from JSC and Abodo cladding. Abodo is a great New Zealand success story. Traditionally, we have used Pinus radiata as framing and cladding. A pine is a fast-growing softwood. The heartwood and the softwood, or the hardwood and the sapwood of the tree, are really hard to tell apart from each other. And so the structural quality of this timber is actually compromised because it is so fastly grown. It's not dense, it's prone to rot and decay due to borer, other insects. So this timber is treated with either a boron treatment or a copper chrome arsenic treatment, which is CCA, to make it more durable. So these chemicals do not create healthy buildings, and these using other timber types is problematic due to cost. Other timber types, their availability isn't great, so it's really hard to get hold of other timber types because most of the forest is geared towards this pine. Also, our timber codes are geared towards pine, and our testing plants for the structural integrity of the stuff that's milled, again, is geared towards this pine industry. So it makes it really hard when you want to use an alternative timber. What is exciting about this thermally treated pine is that we get a far more stable product that doesn't rely on coatings such as paint or oil to keep it durable. JSC's Lunawood is guaranteed for 15 years without having a coating on it. And claddings by law have to be durable for a minimum of 15 years. And so our Lunawood cladding from JSC will do that without oils and without paints. Whereas pine, that's not thermally treated, that has boron or CCA, will not. So we're taking a commonly grown, poor performing product and we're using new technology to create something better. And we can still use sustainably grown timber because pine forests obviously means that we're not going in and milling all the old hardwood rainforests. So we can use this fast growing sustainable timber to create a durable low carbon material and solution. Lastly, there's Louvretech solutions. Now, when I was talking in the mechanical heat recovery ventilation stage, I was saying that there's other ways to reduce overheating. A big key part of building better means we reduce the heat loads on our buildings from weather conditions. So our building envelope is the barrier between a constant internal environment that we want to constantly keep for our comfort and the external environment, which has variable weather and climatic conditions. So the parts of our building that create overheating is actually our windows, because we get solar gains through these windows, which is wonderful free heat in winter. So when we get these solar gains in winter, we don't call it overheating. But in summer, when we don't need as much heat for our comfort levels, obviously if we let in too much heat and unwanted heat, we're going to saturate our spaces and overload our spaces with these free solar gains. So the sun works on two factors. Firstly, it's altitude in the sky. So the altitude of the sun is obviously higher in summer than in winter. And secondly, it's azimuth, which is the angle of its path relative to north and plan. So in summer, we have a wider path. So therefore, we have more solar hours because the sun rises more in the southeast. In winter, it rises more in the northeast. And it sets more in the southwest, whereas in winter, it sets more in the southeast. So we get more solar days in summer, and also the sun is higher. And because the angle of the sun is different in the summer and the winter, we need different shading solutions, and Lunawood is able to offer us. We need horizontal shading in the north because obviously the sun's angle is swinging between east and west, and we can have vertical shading, or we can use horizontal shading, but we can use vertical shading on the east and the west because obviously the sun's angle is a little bit more constant. So we need vertical and horizontal shading solutions. We also need, apart from that, we need a flexible adjustable shading. So the reason for this is that we tend to think about designing for passive solar gain. We tend to think about designing for summer and winter, and often people refer to the summer solstice and the winter solstice. But there is these two seasons in between summer and winter called autumn and spring. Now, I was talking about the azimuth and the altitude of the sun. The altitude and azimuth in autumn and in spring is the same, but our temperatures that we experience and the climatic conditions that we have in autumn and spring are different. In autumn, our temperatures tend to be higher and our weather tends to be drier. In spring, our temperatures tend to be lower and our weather tends to be wetter. So on top of having a combination of horizontal and vertical shading solutions, we also need to have adjustable shading solutions so that we can allow those free gains in spring where we can take advantage of them because our temperatures are lower, but that we can also block them in autumn when our temperatures are higher and we want to avoid overheating in autumn. So Lunawood have solutions that are able to do that, and those solutions are located outside of the building. So here's the core reason for this blog or this vlog is it's very easy to view the choice of material specified in a system and or a system in a design or some shading system as this lovely, aesthetically pleasing, architecturally designed, architect chosen feature. And maybe we won't put it in because budget's, a little bit tight. But when we design better performing buildings, we are often designing with specific intentions and knowledge about why and how we are using these products and these systems and how we're putting them together. A house is a machine for living in, and these components work really well together to either make or break performance in a design. So this is why I say when a builder comes on site and you don't have your architectural designer or your architect along for on-site observation and you don't understand why these products have been used, it's very easy for them to be substituted out. And what's happening is you're compromising the performance and you're missing out on this opportunity of getting a better building. So if you're wanting to build a better performing home, come have a chat. There are key considerations to get early on with regards to systems, materials, and specifications. And we want to get that right at the start and to get the right people on board so that we can make these building better solutions work smartly, not only just for your design, because we do need smart, affordable design and efficient design, but we also need smart, efficient, affordable building processes. So we want to get the right people on board to make that happen for you. Book a chat in the link below. I really look forward to hearing about your project and what kind of better performing home you're wanting to create.